We now are able to talk of the early days of AI, having looked at the dimensions, having looked at the general growth of AI. In late 1955, Alan Newell and Herbert Simon developed the logic theoretist. This can be considered as the first AI program. The program, representing each problem as a tree model, attempt to solve it by selecting the branch that would most likely result in the correct conclusion. However, it was in 1956 that John McCarthy organized the Dartmouth Summer Research Project on Artificial Intelligence. And in fact, from that point on, the field came to be known as artificial intelligence. The Dartmouth Conference served to lay the groundwork for future of AI research. The term artificial intelligence was first used in their document. They said, and I read here for you, we propose that a 2-month, 10-man study of artificial intelligence be carried out during the summer of 1956 at Dartmouth College in Hanover, New Hampshire. The study is to proceed on the basis of the conjecture that every aspect of learning or any other feature of intelligence can in principle be so precisely described that a machine can be made to simulate it. McCarthy, Minsky, Rochester and Shannon, August 31, 1955. In fact, John McCarthy is one of the founding fathers of artificial intelligence, together with Marvin Minsky, Alan Newell and Herbert Simon. We now have looked at the dimensions of AI and have realized that we could be either thinking humanly, thinking rationally, acting rationally, or acting humanly. These leads us to two distinct concepts of AI, the weak versus the strong AI. The weak AI is aimed at building machines that act intelligently. Now, they do not take a position on whether or not the machines actually are intelligent. Whereas strong AI is a field which is devoted to building persons. As Charnock and McDermott concede in their classical introduction to AI, that we are very far from achieving what is strong AI. However, the ultimate goal of AI, which we are very far from achieving, is to build a person, or more humbly, an animal. Charnock and McDermott do not say that the ultimate goal is to build something that appears to be a person or acts like a person. Their brand of AI is so-called strong AI, an ambitious form of the field aptly summed by Hoagland. The fundamental goal, according to Hoagland, is not merely to mimic intelligence or produce some clever fake, not at all. AI wants only the genuine article, machines with minds, in the full and literal sense. This is not science fiction, but real science, based on theoretical conception as deep as it is daring. Namely, we are at the root computers ourselves. And this is where Nielsen's definition of AI is interesting to note. The goal of work in AI, according to Nielsen, is to build machines that perform tasks normally requiring human intelligence. Whether it copies the way human intelligence works is not clearly specified. But we would love to have it perform tasks that would require intelligence. So what is involved if some AI system has to work that requires intelligence for a human being to do the same work? We would need interaction with the real world. That is, the system should be able to perceive, understand, and act. It would involve things such as speech recognition, image understanding. The next thing would be reasoning and planning, involving modeling the external world, planning and decision making, and deal with unexpected problems and uncertainties. Thereafter, any intelligent system should be able to learn and adapt. That is, should have internal models which would be always updated. For example, a baby learning to categorize and recognize animals. Such an work would therefore involve a huge number of disciplines contributing and interacting with each other. One of the disciplines that has made large contribution to the growth of AI is philosophy, where we had looked at one of these ideas of logic. Then they have contributed to method of reasoning, mind as a physical system, to the foundations of learning and language rationality. The next area that has contributed hugely to the growth of AI is mathematics, involving formal representation and proof theory, algorithms, computational decidability, tractability. The other area that has contributed to the growth of AI is statistics and probability, which involve modeling uncertainty and learning from data. Of course, economics have had a huge impact on AI in theories such as theories of utility and decision theory. In this course, we would definitely look at some formal representation, and we will look at modeling uncertainty and learning. We would of course look at decision theory. The other area that has influenced AI in a huge way is the growth of the area of neuroscience, or neurons as information processing units. As we will see later, these developments in this area has in fact moved the course of AI in a huge way. Psychology and cognitive science, as I told you before, has made a huge impact in the area of AI. We look at how do people behave, perceive, process cognitive information, represent knowledge. Our understanding of these processes allow us to develop artificial intelligence systems that can do the same thing. In fact, the growth of cognitive science has also been pushed by the growth of AI, particularly machine learning. Next area of study that has made AI possible and pushed the frontiers of AI is the area of computer engineering. Having fast computers has made a large impact. And then control theory that talks of designing systems that maximize an objective function over time has pushed the growth of AI. One area which have made a huge impact in the way artificial intelligence systems have developed over the years is the area of linguistics, particularly knowledge representation and grammars. In this course, we would look at knowledge representation, we would look at neurons as information processing units, we would definitely do representation of knowledge in cognitive science and psychology. Let us now look at a brief history of AI and try to understand how the area has evolved over the years. As I told you in the previous slide, the earliest beginning of AI was in 1943 with the Macklow and Pitts Boolean circuit model of the brain, which is about the neural model. In 1950s, we had the initial promise with, of course, Turing's interesting and seminal paper on computing machineries and intelligence. We have Samuel's checker program, which we will talk of in our module on machine learning, which was the first program of machine learning. In fact, the Samuel checker program running on an IBM machine, playing checkers with a human, could defeat a human and was very popular at that point of time. We had very early AI programs like Newell and Simon's logic theorists. These were very initial promising enterprises in the area of AI. The enthusiasm continued for the decade 55 to 1965. With the Dartmouth meeting came the term artificial intelligence. Very shortly thereafter, Newell and Simon came up with the general problem solver, which we have discussed in one of the previous slides. Thereafter, there was the geometry theorem prover, and John McCarthy came up with the programming language called Lisp. However, very soon the reality dawned. There was a realization that many artificial intelligence problems are intractable. People soon realized the limitations of existing neural network methods. And in fact, people left neural networks as something that would not make any great impact. However, between 1969 and 1985, people were starting to realize that domain knowledge is something that could change the tilt. Development of knowledge-based system was growing, and there are a lot of success stories. Success of rule-based expert systems such as Dandrel, Mycin. But these were too brittle, and they did not definitely scale well in practice. However, starting with 1986, we had the rise of machine learning. Neural networks again returned to popularity, albeit with a lot of other modifications, which we will look at in our module on machine learning. There were major advances in machine learning, both in terms of algorithms and applications. Beginning of 1990, people started to talk of uncertainty, the role of uncertainty in machine learning and in AI in general. They looked at Bayesian networks for knowledge representation. 1995 is a turning point when artificial intelligence started to be accepted as science. During this period, there was integration of learning, reasoning, knowledge representation. AI methods started to be used in vision, language, data mining, and a lot of other real-life problems. If we now look at the history of AI, let's focus on this slide. Up till 1980-85s, you would see that AI research was involved in its initial euphoric concepts. Beyond 85, machine learning took over the area of AI roughly. This period of AI, we were no longer concerned with the general AI problem and can be categorized as narrow AI, AI with very focused attentions, problems which are really focused and do not talk of a general AI concept. It is expected that as we make more progress in machine learning, we would be able to apply intelligence to any problem, near human level intelligence, and would go back to our general AI problem. But it is very uncertain when that would happen. Here is a very important book that you need to pursue in this first module of the course. This is Artificial Intelligence, a Philosophical Introduction. This is by Jack Copeland. The book reviews the progress made in AI since the inception of the field in 1956. Copeland goes on to analyze what those working in AI must achieve before they can claim to have built a thinking machine. The next book is The Quest for Artificial Intelligence by Niels J. Nielsen. The most important thing on this book is the end of chapter notes, which has citations to important materials, which is of great use to AI scholars and researchers. In fact, the book traces the history of the field that has captivated the imagination of scientists, philosophers, and writers for centuries. A third book that I would love to refer to for this module of the course is Machine Learning, the New AI, a concise overview of machine learning, computer programs that learn from data. In order to understand what lies in the new challenges for artificial intelligence. So this was all about this lecture of the first module of the course, Introduction to AI. Thank you very much.